Hi students. So we're working with chapter 6 lesson 1, weather. And weather are the atmospheric conditions that are happening at a certain place at a certain time. And even though we discussed that as a bell ringer last week, some of you missed it because you didn't say at a certain place at a certain time. So like right now in Rocheville today, August 24th, 2021, it's storming. We have a weather system that moved in, and we have storms today. Lightning and the whole works. Lightning, rain, the whole works. All right, so the variables, the 8 variables that we need to look at are air temperature, and what that is the average kinetic energy. When you measure temperature of anything, you're measuring the average kinetic energy. Kinetic energy is the energy of motion. So as you have more kinetic energy, you create more friction. More friction creates more heat. So it's like when you rub your hands together, if you rub them really fast, and you can feel the heat coming off of the friction. Engines, car engines, and motors heat up because of friction. So, and that's kinetic energy. It's energy that's moving, and so they're colliding with each other, and it creates higher temperature. All right, we use a thermometer to measure that, and locally, well, in the United States, we typically discuss it in Fahrenheit. Very rarely do you see forecasts that talk about Celsius because we're used to Fahrenheit, even though the SI unit is Celsius. All right, air pressure. You have a really good diagram on page 192 in your book. This diagram right here. So you might look at it again, or even check it out while you're listening to this if you can. So if you look at that diagram, well, let me try to do it this way. If you look at that diagram, there's more air molecules at lower altitude. It's more dense. We've done 2 labs now where we talked about density. Density is how packed in everything is, mass per volume. So if you have a high mass and a small volume, it's very dense. If it's very dense, it's going to create more pressure. It seems logical, right? If it's more dense, it's going to create more pressure. So altitude, have you heard of altitude? Like in the mountains, you're going up higher and higher into the altitudes. The altitudes get higher and higher and higher. You're going up, 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 up. Airplane, high altitude. They have to pressurize the cabins in airplanes because you'll lose so much air pressure, because there's the air molecules are all spread out so much they're not creating pressure, they're not packed in. At Earth's surface, you have high pressure, low altitude. As altitude increases, air pressure decreases. They have an inverse relationship. They go the opposite direction. As altitude decreases, we're getting closer and closer to the surface of Earth, or maybe we're going from the mountains to the valleys, air pressure is going to increase as you make your way. Okay? They go in the opposite direction. Athletes sometimes have to go early, especially athletes that are running, have to go before the race. If they're going to a different altitude, they'll go a few days ahead of the race so that they can get used to the difference in altitude, and it affects their breathing, how well they get oxygen to their muscles. So, air pressure, it's measured by a barometer. Okay, air pressure is measured by a barometer. Wind, we talked about wind in class yesterday, but if you weren't here, I need to go over those. We look at the direction that they're coming from. The westerlies are coming from the west, and usually from the west, if I remember correctly, those are usually going to bring us some moisture in the air, if I remember correctly. Direction and speed. An anemometer looks like cups. Anemometer measures speed. So The cups capture the wind that's moving, and it spins, and it can actually measure how fast it's spinning. So that's an anemometer. You've probably seen those before. That's an anemometer, and it measures speed. If I want to measure the direction, you might see one of those. Have you seen at the airports? They have those long orange, they're called socks, the long orange fabric, looks like some kind of plasticky fabric stuff that's really long, and it gets narrow towards the opposite end. It's open on one end. It tells the pilots what direction the wind is moving. So that's important. Direction and speed are important when it comes to wind. On a really high wind day, you need to know that that's going to happen so you can take precautions and batten down the hatches. All right. Humidity. Humidity is how much water vapor is in the air. A lot of us can feel the humidity, or our hair tells us there's humidity, it gets frizzy. How much moisture, water vapor is in the air. And sometimes it makes it feel like it's hard to breathe because it gets so high. Now, relative humidity is a comparison. How much humidity is actually in the air compared to the saturation point? When will the air be saturated 100%? So it's a percentage when you do a comparison. How much is it, and how close is it to the saturation point? So that's a comparison, and you'll see it in percentages. And the way they measure that is a psychrometer. A psychrometer measures relative humidity. Dew point. The dew point is the temperature at which air is saturated and then condensates and creates dew. We've all experienced dew. In the morning, if you walk on the grass and it's all wet and it hasn't rained, that's dew. Or your vehicle's sitting outside and it hasn't rained and it's covered with water droplets because of dew. It's reached the dew point. It's interesting that you could kind of see if there's going to be fog the next day, the next morning, and maybe wish for a fog delay. If the dew point and the morning temperature are the same, then clouds will form. Because of that condensation, clouds will form at Earth's surface if there's enough water. It won't be on a really dry day. That's not going to happen. You're not going to have enough moisture, water vapor. But after a rain, the following day, like it rained at night, then the following morning, the dew point and the morning temperature are the same temperature, then you could have fog. Okay? Be familiar with how to read this graph. Reading graphs and data tables and stuff is an important science skill. So if you look at page 193 and you look at that graph, for example, at the temperature of 30 degrees Celsius, the maximum water vapor, the saturation point, would be 3 grams per cubic meter. So check that out and make sure that you understand how I came up with that. All right. You know how clouds form, right? Condensation. And I'm going to hit that in just a minute when I talk to you about the water cycle. So there's 4 types of precipitation that the book wants you to know the diagrams for those, and you need to look at those diagrams and understand. The pink means it's warm, and the blue means it's colder air. So notice what happens with sleet. So it got cold enough to freeze, and then it fell and went through a real thin layer of warm air, so it started to melt again, and then it continued to fall through some colder air again, and that's how you get that sleet. And if you think about that process, it really makes sense to the days that you noticed that we had sleet. All right? Sorry, my room lights think I'm not in here. Hail. Warm air pushes it back up. It gets another layer. It's cold up here. It gets another layer added on. If it falls and then gets pushed up again, another layer, and that's how the hail gets bigger and bigger, depending on how many times it's pushed back up and how much it's able to latch onto. All right. Snow is just frozen, solid. It's a solid form of precipitation, and then raindrops condensation falls through, and it's warm air below. So, all right. The water cycle on the bottom of page 195. Check it out. Okay, so the energy, how that's related to weather is the energy from the sun. All the energy comes from the sun. The energy from the sun can give enough energy to the surface water, and it can happen on ground too. It doesn't just have to be a body of water. It can actually pull it off of the ground as well if there's water on the ground. Right now there's not a whole lot of water in the ground around here. Well, there is now that it's storming today. But the areas that didn't get it, the ground is like cement. It's so dry. It evaporates it. It gets so warm that it evaporates that water. It breaks the bond between the water molecules. It breaks that bond and evaporates it, moves it up into the atmosphere. The atmosphere is colder, and that's how clouds then form, is because of it's a colder atmosphere. What happens to water vapor when it cools? It contracts and it condensates. The outside of your Coke can, if you leave it, it gets condensation on the outside, or your iced tea, your glass of cold iced tea, gets condensation on the outside. Same thing is going on in the atmosphere, creating these clouds. If it gets enough water molecules and it gets heavy enough, it's going to fall back to Earth. Sometimes it's about wrapping around dust particles and stuff like that as well. So it falls back to Earth as precipitation, and then it, depending on what's going on at the surface, when it precipitates, it'll determine what kind of precipitation it is, whether it's rain, snow, sleet, or hail. Okay, hopefully you understand all of that. And then the cycle just keeps repeating itself. So then it falls, it goes into water, or it goes into runoff, it goes into groundwater. The sun evaporates, gives it energy, evaporates it, and it's a continuous cycle. All right, I think that's everything that you need in order to be successful with answering the questions 1 through 9 on page 196 on paper, so you can turn it in. Those of you at home, you can take a picture of it and submit it to, I guess, take a picture of it and email it to me. Do that, because if I put it out, well, I'll put it in Google Classroom. Submit it in Google Classroom and I'll grade it from there, because I can have the rest of the kids, we're going to grade them in class, so I can have the rest of the kids also submit it instead of giving me the paper copy. So let's do that. Submit it back to the Google post, 196, 1 through 9, okay? I pushed it out in your textbook as a homework assignment or a class assignment.